Here we want to find the integral of 1 divided by 7 minus x squared to the 5 halves. Think of this as a squared minus x squared. So since we have the expression a squared minus x squared, we would use the suggestion x equal to a times sine of theta. So first, let a squared be 7. A will be the square root of 7. Use the suggestion x equal to a times sine of theta, or the square root of 7 times sine of theta. The derivative of x with respect to theta is the derivative sine of theta, which is cosine of theta. So we have dx is equal to the square root of 7 times cosine of theta times d theta. Now let's write the expression 7 minus x squared to the 5 halves in terms of theta. 7 minus x squared to the 5 halves. This is the fifth power of the square root of the second root. So it's the fifth power of the second root. So we can write it as the second root of 7 minus x squared to the fifth power. X is the square root of 7 times sine of theta, and so we have x, the square root of 7 times sine of theta. The square root of 7 times sine of theta is 7 times sine of theta squared. Common factor of 7, so we have 7 times 1 minus sine squared. 1 minus sine squared from trigonometry identities is cosine squared. So this will be the square root of 7 to the fifth The inside here is the same as this. This is the square root of 7, and then the square root of cosine squared is just cosine theta. And then separate the factors here, so this will be the square root of 7 to the fifth, cosine of theta to the fifth. The original integral now is equal to 1. So the expression 7 minus x squared to the 5 halves is 1 over, would be 1 over the square root of 7 to the fifth times cosine to the fifth. Dx is the square root of 7 cosine of theta d theta. So dx, the square root of 7 cosine of theta d theta. And so we have the square root of 7 over the square root of 7 to the fifth. And then cosine dividing by cosine to the fifth. This will be 1 over 49. Cosine dividing by cosine to the fifth is 1 over cosine to the fourth. 1 over cosine to the fourth is secant to the fourth. Well, let's write secant to the fourth as secant squared times secant squared. And then rewrite the first secant square as tangent square plus 1. And the reason we want to do this because we will use u substitution here and let u be tangent of theta, and the derivative tangent of theta is secant square. And so that's why we rewrite the first secant of square theta as tangent square theta. And so now let's find this integral right here. So we'll let u be tangent of theta. Du d theta will be secant square because the derivative tangent of theta is secant square theta. And then du will be secant square of theta times d theta. And therefore this integral is equal to u squared plus 1 because u is tangent of theta. Secant square theta d theta, that's just du. Antiderivative of u squared is u to the third dividing by 3. Antiderivative, the constant 1, is just u. U is tangent of theta, so we have tangent of theta to the third dividing by 3, and then u is tangent to the third. So the original integral was 1 over 49 times this integral, but we just found this integral to be thus. So this will be 1 over 49 times the tangent of theta to the third dividing by 3 plus tangent of theta. The original problem was in terms of x, so we need to rewrite tangent of theta in terms of x. Earlier we have x is equal to the square root of 7 times sine of theta. Dividing both sides by the square root of 7, we get sine of theta to be x over the square root of 7. Sine of theta, by definition, is opposite over hypotenuse. This is the angle theta, this is the opposite side, this is the adjacent side, this is the hypotenuse. We have a right triangle here, so it will be the opposite side squared plus the adjacent side squared is equal to the hypotenuse squared. For this problem, the opposite side is x, the hypotenuse is the square root of 7. And we're looking for the adjacent side. Opposite side is x. The adjacent side, that's what we're looking for. The hypotenuse is the square root of 7. Square root of 7 squared is just 7. And then subtract x squared from both sides. Then we get the adjacent side square is equal to 7 minus x squared. And then take the square root of both sides, we get the adjacent side is the square root of 7 minus x squared. Tangent of theta is opposite over adjacent. The opposite side is x. The adjacent side is the square root of 7 minus x squared. So this is tangent of theta in terms of x. And so the original integral is equal to 1 over 49 times tangent of theta to the third time dividing by 3 plus tangent of theta. Tangent of theta is x dividing by the square root of 7 minus x squared. So in the place of tangent of theta, we have x over the square root of 7 minus x squared. And x over the square root of 7 minus x squared. 49 times 3 is 147. And then we have 1 over 49 times this expression, so we get 1 over 49 times x dividing by the square root of x squared minus dividing by the square root of 7 minus x squared. And this is the answer.